Welcome to Preline. Today's session, we are discussing about quantum computing using C-sharp and Q-sharp. Please follow my site to get more understanding about quantum computing and quantum neural network. This is my site. This is the quantum section. You can understand what is quantum computing, superposition, and entanglement. Before getting into the coding part, we should understand what is quantum and how we can apply the real world application. Many of the videos are in the internet about quantum computing. Why they are so confusing? Let's see. First, what is quantum? The physicist Max Planck in 19th century proposed that at the subatomic level, energy is contained in tiny discrete packets called quanta, which behaves as both waves and particles, depending on their environment at time. For example, light. Light is a particle or a wave. Particles, bounces, move by collision, cause other things to move, have mass, momentum, travel in straight lines. Those are the particles. The waves act like sound, interfere, diffract, refract, can cancel another, create a new waves. So what is quantum computing? Quantum computing is the use of quantum mechanical phenomena such as superposition and entanglement to perform computation. The computers that perform quantum computations are known as quantum computers. Quantum computers are believed to able to solve certain computation problems such as integer factorization, that is the encryption, and the drug discovery faster than the classical computers. This is the sample diagram of quantum and the classical bits. So what is classical bits and qubits? The classical computing method we use today work on chips that process all data using 2 bits. Those are 0 and 1. The classical computers are encoded the information using bits 0 and 1. Even the most complex data or algorithm, your inputs gets broken down into these 2 bits, 0 and 1. The quantum computers are not going to replace the classical computers. So this is the example of bits and the qubit. The quantum computing uses the unit as a qubit, the short for quantum bits. For example, if you are using classical computers in the sense, it's a 2 cross n formula has been applied for the bits. For example, if you are using 10 bits in the sense, it's 2 cross 10 in the sense 20 bits. If it is the quantum in the sense, it's a 2 to the power n formula, which means if you are using the 10 bits in the sense, it gives you 1024 bits combination. Let's see the example video. So this is the example. Here it mentions that. So this is a 2 into n. This is the classical computer formula. If you are multiplying into bits in the sense, it gives you the multiplication of that. The 2 to the power n formula for the quantum bits. So if you are increasing every single bit, it will increase the bit size. For example, flip a coin, either heads or tails. In a quantum computing, we may have the combinations of both heads and tails as an input. While spinning, you can see both positions. In quantum physics, these qubits could be electrons or protons orbiting a nucleus in an atom. The superpositions and entanglement are the key principles of quantum. Let's see. What is quantum superposition? These quantum particles or qubits may exist as both 0 and 1 at the same time. This is the phenomenon known as superposition. This is the image. We can see either cat is alive or dead based on the state of blast. Let's see the example. Here, the cat is it's in the box. Either the box with the bomb, the cat may be alive or dead. The both phenomena can be happen. So it can have the both combinations of alive and dead. Similarly, the bits in the sense it has both combinations of zeros and one together. This is superposition. What is quantum entanglement? Entanglement is the state of one is dependent on the other state. Entanglement happens when two qubits in the superpositions are correlated with one another, which means two members of a pair exist in a single quantum state. Changing the state of one qubit will instantaneously change the state of the other one in a predictable way. This happens even if they are separated by very long distance or a spooky action at distance. Example, the particle 1 has both spin up, spin down. Similarly, particle 2 will be having the same spin up and spin down. The possibilities of spin either both spin up, spin down, or one spin up and another spin down. Similarly, one spin down and another spin up. The measurement of one is spin up means that will pass the value to the second particle, then it gives the spin down. This is called passing the value at distance or spooky action at distance. So how the measurement is passing the values, we can see the example here. Here it travels two particles. When these two particle measurement will be transferred between both in the sense it will perform faster than the light. You can see the example here. So whenever they are able to pass the measurements of both values, it performs faster than the light. There are two particles. Particle 1 has A and B combinations of input. Similarly, particle 2 has the A and B combinations of the input. If particle 1 gives you the output A, means it passes the value to the particle 2. Then the particle 2 analyze that already the particle 1 output is A, then it by default its output is B. This is called quantum entanglement. There are different companies have been released the quantum computing for development. If it is IBM in the sense Qiskit, Microsoft Quantum Development Kit, D-Wave, Ocean, Xanadu, Penny. Since I am from Microsoft background, I have chosen the Microsoft Quantum Simulation using QSharp. To use qubits, we should have more RAM memory. Let's program how to use QSharp in C Sharp. This is the quantum teleportation. It's like a simple hello world example. This document explains you quantum teleportation perfectly. What is the one qubit gates and what are the X gate, Z gate and Adamant gate. Similarly, two qubit gates in the sense it comes under that C naught gate. C naught gate we are using in QSharp for entanglement. Let's see the example how they have written in QSharp. Here, this is called superposition, and C naught is an entanglement of both. Similarly, this is called the entanglement. This is the superposition. The qubit has been mentioned here. For example, if you want to use two qubits in the sense you are using qubit 2 and one has been assigned to message and one has been assigned to target. So here we are applying the X naught gate. So these kind of logics we should understand before getting into the Q sharp. So this is how the Microsoft using the quantum simulator in C sharp. Similarly, Microsoft has given the documentation and the sample applications. It's almost same as like shown you the example previous one. So here the teleportation says that this is the H gate, in the sense Hadamard gate. It works as like a measure superposition, and C naught gate, it performs like an entanglement. If you want more understanding about quantum computing, get into the Microsoft documentations. Thank you.